Alex, there's a specific kind of heartbreak that only happens in the dark. It's that moment you're halfway through a perfect rip cut, the grain is looking beautiful, the blade is singing, and then clunk. The whole shop goes black because your wife decided it was a good time to run the toaster and the treadmill at the same moment.
I've seen that look on your face. It's less master craftsman and more toddler who dropped his ice cream. But seriously, how are we still tripping breakers? This is a garage, not a dollhouse.
That's exactly the problem. Most builders wire a garage like it's a place to park a car and maybe plug in a single light bulb to find the windshield washer fluid. They give you one 15-amp circuit for the whole zip code. You try to run a cabinet saw and a dust collector on that, and you're basically asking the copper wires to provide a light show inside your walls.
Which is why we're doing the deep dive today. We're talking electrical planning. And before anyone starts stripping wires with their teeth, we should probably mention we aren't electricians, right?
Oh, absolutely. I've got enough gray hair without adding high voltage shocks to the mix. If you're not comfortable, hire a pro. In some places, like Arizona, you can do your own work if it passes inspection, but you've got to know the why behind the how.
Okay, so let's start at the heart of it. You're always preaching about the sub-panel gospel. Why can't I just run 3 really long extension cords from the kitchen?
Because I'd like you to stay alive, for starters. Think of your main house panel like a giant water main. If you try to pull all your shop power through one tiny hose, the pressure drops. That's voltage drop, and it's a silent killer for motors. It makes them run hot, and heat is the arch nemesis of that expensive table saw you just bought. A sub-panel is like putting a dedicated reservoir right in the shop.
So how big are we talking? Give me the numbers.
For a one-person shop, 60 amps is your get-out-of-jail-free card. It covers your lights, a beefy tool, and the vacuum. But honestly, if you're pulling the wire anyway, go for 100 amps. The price jump between a 60 and a 100 amp box is basically the cost of a mediocre lunch. And it means 10 years from now, when you buy that monster TIG welder or a CNC machine, you aren't crying in a dark shop again.
You mentioned a power audit earlier. Is that as boring as it sounds?
It's basically just a grocery list for electricity. You look at the little metal plates on your tools. A table saw might pull 15 amps. Your dust collector pulls another 12. If you flip them both on at once, which you should unless you like breathing sawdust, you're already at 27 amps. That 15 amp builder grade circuit, it gave up and went home 5 minutes ago.
So you're planning for the simultaneous load, the stuff running at the exact same heartbeat.
Exactly, and don't forget the hidden stuff, the LED shop lights, the radio, the battery chargers, and, if you're like me, the space heater that keeps your fingers from turning into icicles in February.
Okay, let's talk about the actual boots on the ground stuff. I saw you using a story stick when you were marking out your wall boxes. Is that just you being fancy?
It's the opposite of fancy. It's being lazy in the best way possible. Instead of pulling a tape measure 50 times and getting 50 different heights because I'm squinting at the lines, I take a scrap piece of 2x4 and mark it at 44 inches.
Why 44? That seems specific.
Because plywood comes in 4-foot sheets. If you put your outlets at 12 inches off the floor like a living room, the moment you lean a sheet of Baltic birch against the wall, your power disappears. At 44 inches to the bottom of the box, the outlet sits right above the top of a sheet or your workbench. You aren't playing hide and seek with the plug every time you need to sand something.
That's actually brilliant. And what about the boxes themselves? I've seen the tiny ones and the ones that look like they could hold a sandwich.
Go deep. Always go deep. I use those deep hammer boxes. Trying to cram 3 12-gauge wires and a GFCI outlet into a shallow box is like trying to put an elephant into a tuxedo. You'll just end up frustrated, with sore thumbs and a potential fire hazard from pinched wires.
I've heard you complain about daisy chaining before, but then I see you doing it. What's the catch?
There's a right way to do it. You don't want the power for the whole wall running through the tiny brass tabs on a cheap outlet. If that one outlet fails, everything downstream goes dead. I like to use pigtails. You connect the incoming and outgoing wires with a wire nut and just have one little tail going to the outlet. It's like a bypass lane on the highway.
Practical. Now let's talk 240 volts. For the average person, that sounds like danger zone territory.
It's just big boy power. If you're serious about woodworking or metalwork, 240V is your best friend. It lets you run larger motors more efficiently. A 3-horsepower saw on 240V starts up with a confident thwump instead of a pathetic whir clunk. When you're wiring the shop, even if you don't have a 240V tool yet, run at least one circuit for it. Future, you will want to buy you a beer for that decision.
What about the conduit? I see some shops with wires hidden in the walls and others with metal pipes everywhere. Is that just an aesthetic choice for the industrial look?
It's often about whether the walls are finished. If you have open studs, Romex, that's the plastic sheath stuff, is fast and easy. But if you've already got drywall up, surface mounting EMT conduit is a lifesaver. Plus, it protects the wires. In a shop, things fly around. I've seen a kickback on a table saw send a chunk of oak right through a piece of drywall. If that hits a wire, bad news. If it hits a steel pipe, the pipe just laughs at it.
A laughing pipe. Got it. What about the nail plates I saw on your shopping list?
Oh, those are the oops protection. You steel plate the studs where the wires pass through. Because eventually you're going to want to hang a heavy tool cabinet, and without those plates, you'll drive a 3-inch screw right through your new electrical run. I may have done that once. The sparks are pretty, but the repair job is miserable.
We can't talk electrical without GFCIs. Is it true they're extra sensitive in a shop?
They can be nuisance trippers if you have an old leaky motor on a vintage lathe or something. But look, shops are often damp, or we're working near garage doors. A GFCI is the difference between a zip and a heart stopper. Usually, I put one at the start of the circuit so it protects every outlet downstream.
Last thing, lighting. You used to work in what looked like a cave. Now your shop is brighter than a surgical suite.
Lighting is safety. Period. If you can't see the grain, you can't see the blade. I tell people to put the lights on their own dedicated circuit. There is nothing more terrifying than a table saw blade spinning at 4,000 RPM in total darkness because your dust collector tripped the breaker. You want the lights to stay on even if the tools quit.
That's a haunting image. The spinning blade in the dark. Sounds like a bad horror movie.
It's a horror movie where the ending involves a trip to the ER. We avoid those.
So, the big takeaway today. Plan for the shop you want, not just the shop you have.
Exactly. Overbuild the infrastructure. You can always buy a better chisel later, but ripping out drywall to add a 20-amp line is a chore that'll make you want to take up knitting instead.
And use a story stick so your outlets don't look like a drunk person installed them.
Precisely. Respect the copper, keep your lights on a separate loop, and maybe buy a sub panel that has more room than you think you need. Your future self is waiting to thank you.
Thanks for the walkthrough, Tiger. I think I'm actually ready to go look at my breaker box without flinching.
Just keep one hand in your pocket and your eyes on the schematic. We'll get that shop humming.